Hello, and welcome to the Ubuntu tutorial for the multi-GPU cloud classification code. For the purposes of this demonstration, I will be using an AWS Deep Learning AMI on Ubuntu 18.04, and this instance has 4 NVIDIA Tesla T4 GPUs. So once you get into your instance, the first step you want to do is you want to make sure that you're using the right version of CUDA that matches up with the cloud classification code. Luckily for us, the AWS Deep Learning AMI actually comes with different versions of CUDA pre-installed, and we can actually switch to the correct version we need, which is the CUDA version 10.2, by using the 2 following commands right here. In this case, I'm just going to simply copy these 2 commands and I am going to run them. So after you finish running these 2 commands, you can actually verify that your CUDA version is correct by running the nvcc version command. In this case, run this. And as you can see, we are using release 10.2. So we are using the right version of CUDA. Next, we'll begin setting up our directories. So you want to create a folder inside your preferred directory in which you will store all the necessary files for the cloud classification program. And for the purposes of this guide, I will refer to the folder as cloud classification. So if you see right here, I have a folder called cloud classification. And I will go into this folder right now. So after you create this folder, what you want to do is copy the necessary dataset files, Florence 10mm, train 10mm, and test 10mm into this cloud classification folder. You also want to copy the requirements gpu.txt file and make an empty logs folder for the TensorBoard profiler log time results. So in this case, you can see this is how I have my environment set up. I have my 3 dataset files, Florence, test, and train right here. I also have an empty logs folder, and I have the requirements gpu.txt file, right? So the requirements gpu.txt file contains all the necessary packages that we need for the cloud classification program to run. So we'll be talking a little bit more about this in just a moment. But first, before we install our packages, we want to create a conda environment with the required Python version, in this case, Python version 3.8. And we want to use this conda environment to install as a place where we can store all the necessary packages that we need. So we can simply use conda create for the purposes of this guide. I'll be naming my conda environment cloud classification. You can name it whatever you want. But just keep in mind that once you name your conda environment, you have to change the name when you use the conda activate command later on. So in this case, I'm going to specify that I want to use Python version 3.8. So I've already run this command, so I will be running it again. But once you run the command, it'll be prompted yes or no whether or not you want to install some initial necessary packages for the conda environment. You want to say yes. So now that we've created our conda environment, we can activate it using the following command. We can use conda activate. And now, as you can see here, we have our cloud classification conda environment active. So now we can use this command to install all the necessary packages that we need. Pip install -r requirements _gpu.txt. So this is very simple. We've made it so that users can install all of the necessary packages for our programs with one command. And when you run this command, it will begin to install the packages for you. If I run this command right now, you'll see that I already have all the necessary packages for the cloud classification code pre-installed. So I've already done this step. All right. Now, this next step is a bit more complicated, but what you want to do is you want to navigate away from your directory, in this case, so home directory. If you're using one of these AWS instances, you want to go to user local CUDA extras cupti lib64. So you want to go to this directory right here. And if you take a look in this directory, you'll notice there's a couple of CUDA library files in here. And you want to use this command right here, sudo cp libcupti .so 10.2. And what this command will do is it will go ahead and it will take a file that already exists in here, in which case is the 10.2 file, and it will rename it into 10.1. Right? And once I've finished running this command, you should notice this 10.1 file right here, right? In which case you've done this correctly. And you can go ahead and you can actually go back to your directory. So in this case, I'm going to go back to my cloud classification directory. Next, we can actually run the cloud classification program using this command right here, CUDA visible devices. Right. So what CUDA visible devices does is it will specify which GPUs you actually want to use. Right. In this case, I have 4 GPUs, GPU 0, 1, 2, and 3. And by specifying that I want to use CUDA visible devices 0, 1, 2, and 3, I'll be using all 4 GPUs. I can also tweak this command a little bit. For example, if I only want to use 1 GPU, I can use CUDA visible devices equals 0, which means I'm only using GPU 0. I can also use only 2 GPUs or no GPUs at all, in which case I'll be using a single pair of single quotes with no contents. Again, for the purposes of this demonstration, we'll be using all 4 GPUs. So once you have this command, you can run this and the program will begin to run. All right. And at this point in time, this might take a bit of time for all the necessary libraries to load. So we might have to wait a bit. All right, so as you can see right here, the program has begun training the first epoch right here, right? And you can actually check to see whether or not all 4 GPUs are being utilized properly by using the NVIDIA-SMI command. And if we take a look here, we can see that we have our 4 GPUs, and right here, we're using each one. Right, so we are effectively using all 4 GPUs in this scenario. So once this program finishes running, what we're going to see is an output, and the output will be for the time or the runtime, right? The time that it takes for the program to run. So that will be outputted at the end for you. All right, and that is it. Thank you for watching this tutorial and have a great day.